I'd like to thank all the ChemAxon people for just hosting a great event and giving me the opportunity to introduce myself and my company. This is my way of saying that this is basically an introduction to Acelot. We are an early stage software chemical informatics startup company, and what I'll talk about today is our core technologies and how we've integrated them and used with Instant JChem, and how ChemAxon has been helpful with that, and a little bit about what we can offer you to help you offer to your medicinal chemists. So our core competency at Acelot is graph algorithms and graph-based data mining techniques. So we're commercializing technology that was developed at University of California in Santa Barbara, and we're doing that in the chemical informatics domain, the mapping of graphs to molecules. I don't need to explain that here. So the two technologies that we have are what we're calling SimFinder, which is basically a topological similarity search. I'm not, well, you can read, I don't need to point. And the other is SigFinder, which is our technology for identifying statistically significant substructures in a chemical database, in a chemical library. So I'll talk about these two things and our integration with Instant JChem, and then pass it on. So our similarity search technology, SimFinder, we are positioning as an alternative to fingerprint and descriptor-based similarity search. And the advantage, well, the disadvantage that we have of being in the graph domain is the computational complexity there. That's the whole reason that we go to fingerprints and descriptors to do chemical similarity search. The things that allow us to search in the topological domain and have that be fast is, well, the first thing is that we have a well-defined notion of edit distance between graphs. So the index, and finally an index that allows the search to take place. So our ordering of graphs is essential for the index creation, and the other essential part of that is that we have isomorphism heuristics that make it possible to map the graphs onto one another in a tractable amount of time. So well, we've used Instant JChem. So we're the technology company, and we're resource limited, and we don't have the resources to recreate a whole beautiful infrastructure for displaying chemical compounds. And that's how we've employed Instant JChem. So we've developed a plugin for Instant JChem, shown here, which will basically index and do similarity queries on a chemical compound database. And I'm showing some results here. One of the advantages that the topological search gives us is an intuitive mapping from a chemical query to the search structures that we come out with. And I think that that's an advantage for a medicinal chemist who's really looking for why is that molecule similar, and we're showing that in a structurally obvious way. So that's the SimFinder, and the second technology that we're exposing through IJC is our substructure mining algorithms. And here I'd like to start with the distinction between frequency and significance. If you're data mining a chemical library, just because a functional group is present at a very frequent level, it doesn't necessarily mean that's significant if the whole background database is filled with that substructure. And we've developed a statistical model that will identify overrepresented and underrepresented functional groups in a chemical library versus a background library. And so this is just illustrating the types of significant substructures that we'll get out of a query. And we've applied this in two domains. One is classification of chemical properties, physicochemical properties, and other just generally finding the insight that helping the medicinal chemist gain the insight into a query or into an assay result that he'd otherwise gain out of hours of structure gazing, and this will help him quantify that. So that's the substructure mining. Just to kind of summarize the benefits there. So for similarity search, we see this as sort of a side-by-side companion to fingerprint-based searches. We can parameterize the distance function that we use for chemical similarity, and that can be helpful on a project-per-project basis. The other advantage I want to point out is that the hits that we get out of a similarity search from our topological-based search are distinct from those that we see out of a fingerprint. And that can give you a new lens on a previously searched database. And when we look at the actives out of that, we're at least better, or at least comparable to fingerprints. And for SigFinder, we see that as a way to quantify the intuition that a medicinal chemist gets out of gazing at the structures of an assay result. And for this last bullet point, what I want to say is that so by staying in the topological graph domain, we can extend our graphs to represent protein-ligand complexes. And we can, in the same way that we have libraries of chemical compounds, we can make libraries of protein-ligand complexes and do similarity searches in that database. And I think that that representation extends in a way that fingerprints don't. So I like to think of that as us bringing chemical informatics techniques to the domain of structural bioinformatics, and structural biology. Okay, I think that's it. For more information, we have a website that's online now, and I'll be at the partner exhibition table, so you can talk to me directly. Thanks.